Hello, you do usually lose marks in these questions, mechanics questions, where you have a particle moving freely under gravity because you get confused with the direction of the velocity, the displacement, the gravity, you make mistakes with the signs. This lesson is for you. So I'm going to explain you what happens so you don't make mistakes ever again. When we have a particle moving freely under gravity, it means because the gravity is constant, or we consider it constant, we have a motion under constant acceleration. So we are going to be able to use Subat equations. The key here is mainly because it changes direction. The particle usually goes up and then down, but even if it just goes down, it's important to choose a positive direction for the vectors. So if we decide that positive is up, and this is completely up to you, you can do the other way around and choose positive down, but it goes more with the vertical and horizontal axis. So you can choose positive up like in the y-axis. It really doesn't matter, but we have to stick to one direction. So that means that any vector that is in this direction is going to be positive, and if the vector is in this direction, is going to be negative. So if you consider a particle that goes up first, the velocity is going to be positive because it's in the positive direction. If the particle then goes down, the velocity is going to be negative because the particle is in the opposite direction to what we consider positive. If we have the gravity, because the gravity is always downwards, in this case, if we choose positive up, our acceleration is going to be minus the gravity. Yeah, so that's how we choose the signs. And the same for the displacement. If we have a displacement and it's down, it's going to be negative. If it was up, it will be positive. So that's where the signs come from, because we are choosing a positive direction, and then for the whole Subat part, we are going to stick to it. We are going to be consistent. Anything that goes up is going to be positive, anything that goes down is going to be negative. And that's it. That's what you have to consider. I'm going to show you a few questions. The other thing that you have to remember is when something is falling, dropped, when you have something falling or dropped, what you know is that the initial velocity is 0. So when something is just falling or dropped, the initial velocity is 0. And when they ask you the maximum height, because we have something that goes up, 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 stops, and then reverses down, the velocity here at the top, final velocity for this bit here is going to be 0. It's not going to be 0 here. It's not going to be 0 here, but it's going to be 0 at the top. So if we need to find the maximum height, we are going to work only with a bit of the motion when the particles goes up. I'm going to remind you, we are going to use Subat equations. Yeah, we have 5 Subat equations. They have to be clear. You need to understand how to use them before doing something moving freely under gravity. They are in your formula booklets. There are 5. They have 5 variables. That's why they are called Subat. They are in the initials of displacement, initial velocity, final velocity, time, and acceleration. And each of the equations is missing one variable. Yeah, if you look at them, all of them are missing one, and that's going to help us to choose the Subat equation. Yeah. So let's do a couple of questions. You have something falling first. So you have a book falls off the top of a shelf of a bookcase. So you have something like this. You have the ground. They say the shelf is 1.4 meters above the ground. So we know that this distance is 1.4 meters. And it falls from here. They ask us first the time it takes for the book to reach the ground. So we need this time here. Yeah, the time that it takes for the book to reach the ground. First thing we are going to do, we are going to write Subat. But that's what I recommend you. So we know what we have. We are going to choose positive up just to choose something. And then we are going to write what we need and what we have. So they are asking me the time. So I need this one. If it's falling, the first thing that I know is the initial velocity is 0. I know the displacement. The displacement, remember, is the difference between the final position and the initial position. So from here, my displacement is downwards. So it's going to be negative, and it's going to be then minus 1.4. It's negative because I start in the initial point and I finish in the last point. Yeah, so my vector is downwards, so that's why it's negative. My acceleration, we say the gravity is always downwards, and because positive is up, it's going to be minus 9.8, and the velocity, I don't need it, and I don't have it. So I need a Subat equation without v. If you remember the Subat equations, are these ones. The one that has no V is this one here. This one is the one that I'm going to use. So I know that S is ut plus 1/2 at squared. S is minus 1.4. U is 0. And then I have minus 9.8 times 1/2 is 4.9 t squared. We can cancel the signs. And then t is the square root of 1.4 divided by 4.9. We get a positive and a negative answer, and obviously the time is going to be positive. So this is the time that it takes for the book to fall. For part B, they ask me the speed with which the book strikes the floor. We need the speed here. We need this V now. So we are going to use a Subat equation where we have V. Which one can we use? The simplest is always this one. Maybe if you're not sure if your answer is correct, I would use one without the time, just because this one could be wrong. So that would be usually my recommendation. Don't use something that you have calculated if you have enough information to not use it. Yeah, that's what I would do. So let's go into do that. If we do that, for B, we will use this equation. So V squared is U squared plus 2AS. V squared is what we need. U squared is 0. And then I have minus, because the acceleration is negative, remember? 2 times 9.8 is 19.6. And S is minus 1.4. Yeah? So that means V is the square root of just those two numbers multiplied together. 1.4. This is 5.24 to 3 significant figures, meters per second. Yeah? Notice that they say speed and not velocity. Remember, the speed is just the magnitude of the velocity. So they are just asking me the number, because this velocity would be downwards, it should be negative. So if they ask you the velocity, probably you could say that this downwards, or you can say that is minus 5.24. Because they ask you the speed, to avoid that, is just 5.24. You just need the number, yeah, the magnitude. That would be one thing that they can ask you. Another common thing is we have a ball is projected vertically upwards from a point X, which is 7 meters above the ground with the speed 21 meters per second. So I have the ground, I have a point X, and this is 7 meters from here. And this is where the particle is projected. So it's going to go up and then down again, right? They say, find the greatest height above the ground, and the initial velocity, sorry, is 21 meters per second. So this is my initial velocity. The greatest height above the ground reached by the ball. Remember, I told you at the beginning, if we are looking for the greatest height, we are going to work only with the part where the particle is going up, not the whole thing. Yeah, we need this displacement from here to here. But because then they say the greatest height above the ground, and we are calculating only from here to here, that's what Subat is going to give us from the point of projection to the top, then we will have to add 7 meters at the end. Yeah, I'm going to do the same that I did in the previous part, in the previous question. I'm going to choose positive direction. I'm going to write Subat and write what I know from here to here. I need the displacement because that's going to be this distance here. The initial velocity is 21, and it's going to be positive because I say positive is up and this velocity is up. Velocity at the top, remember, is 0 because the particle is stopping before reversing and moving down. The acceleration is going to be minus 9.8 because positive is up. Even if the particle is going up, what the positive thing, what this positive is the velocity, but the gravity is still down. Yeah. So in this bit here, the first part of the motion, my velocity is positive, but my acceleration is negative. Yeah. That's precisely why the particle is stopping, because I have a deceleration. Yeah, the acceleration is against the velocity, so the particle will stop and accelerate down. And the time, I don't need it. So I need a Subat equation without time. I'm going to show you again the Subat equations. The one without time is this one here, and that's the one that we are going to use. So V squared is U squared plus 2AS. V squared is 0. U squared is 21 squared, then minus 19.6, so 2 times A, S. And that is 21 squared divided by 19.6, which is 22.5. So the displacement is 22.5 meters, which is this bit here. And that means the maximum height from the ground is this bit plus the 7 meters. So maximum height from the ground is 29.5 meters. Yeah, that's the first part, and it's quite common. They ask you the maximum height, and that's how we find it. Then the time of flight of the ball. Now we have to be careful. We are not going to use this information because this information was only for the first part of the motion. So we were working only up to the maximum height. While for part B, they are asking us the time of flight. So it's the amount of time that the particle is in the air. So we are going to adjust this thing here, right? So I'm going to clean this and write it again. Again, choosing positive up. If I write Suvat, now notice they are asking me the time. The displacement from here to here is a vector down from here to here. What is the direction? Because it's negative, is down, it will be negative, and because the value is 7, it's going to be minus 7. So that's my displacement. My vector displacement is from beginning to end of the motion, remember? So from here to here. And think that this particle is not moving sideways. We represent that way, but really the particle is going up and down. Yeah, in the other thing, you will see particles going sideways, not in the other. Then the initial velocity is positive 21, like before. Final velocity, we don't need, is the velocity here. And the acceleration, because it's downwards, and the particle, and we chose positive up, the acceleration is going to be negative. Yeah, remember this only, the sign only depends on what we have chosen and the direction of these vectors. Yeah, so this vector is negative because it's this way. This vector is positive because it's this way. This vector is negative because it's this way. Yeah. Then we use a Suvat equation without V, which is this one. So we have S is ut plus 1/2 AT squared. S is minus 7, U is 21t, it's a quadratic, and we are going to get one positive value and one negative value for t. Yeah, so if we reorganize, we have 4.9 t squared minus 21t minus 7t equal to 0. We solve that, and we ignore the negative value of t because the time, remember, cannot be negative. You know that. So I get 4. So t is 4.6 seconds to two significant figures, and the other value, if you want to write it and cross it out, is 0.31 seconds. We will cross this one, it's not possible, and the time of flight is 4.6 seconds. So this is going to help you with any questions because all the questions work similarly. They can ask you maybe the amount of time that this is above 15 meters. That's another one that is common. Or they can ask you what is the velocity after 3 seconds, or the time that it takes to reach the maximum height. So the combinations are not really many, but the important thing, and where you make the mistakes, is always with the signs in these questions, always. So choose a positive direction. I would recommend you to choose positive up because we are very used to work with the coordinate axis where the positive is up or the vectors. If not, it doesn't matter, and stick to it. So be consistent in the whole Suvat that you write. So any vector that is downwards is going to be negative. Any vector that is upwards is going to be positive. And then you will be fine. Yeah, I hope it helped. I hope to see you soon. Bye-bye.